to Grade 5, Chapter 9, where we will be teaching you about percents, fractions, and decimals, and the conversions between them. So Section 1, we teach you about percents and fractions, and how to convert each one into the other. So you can think of a percent as a numerator of a fraction with 100 as a denominator. So here's an example. This grid contains 100 small squares. Each square represents 1%. 76 small squares are shaded. So the percent is 76 parts of 100, so it's 76%. But the fraction is 76 parts of 100 too. So it would be 76 over 100. Now, in the simplest form, since 76 and 100 are both divisible by 4, it would be 19 over 25. Now, let's do some practice. Write a percent and a fraction to show the shaded part of each grid. For each fraction, use the simplest form. So there's 100 total parts for each of these grids. And let's count the number of shaded parts. Well, one of these columns is 10, so this is 30, and then there's another 2. So there's 32 shaded parts. That would be 32%. Now that would also be 32 over 100, but that's not the simplest form, since 32 and 100 are both divisible by 4. So then the simplest form would be 32 divided by 4 is 8, and 100 divided by 4 is 25. So the simplest form would be 8 over 25. The fraction is 8 over 25. Now we move on to the next question. So there's 100 total parts, just like all of these other grids, and 2 of the columns are shaded, so that would be 20 shaded parts. That's 20%. And the fraction is 20 over 100. But we know that's not the simplest form because both 20 and 100 are divisible by 20. So that would be 20 divided by 20 is 1, 100 divided by 20 is 5, 1 over 5. The fraction would be 1 over 5. Now, questions 3 and 4 for more practice is, there's 100 total parts, like usual. And there's 10 shaded parts. So the percent would be 10%. But the fraction would be 10 over 100. And, this is easy. 1 over 10. Now, this one has, that's a strange number. There's 47 shaded parts. And 100 total parts. So the percentage is 47%. And because 47 and 100 do not share any factors, the fraction is already at its simplest, so 47 over 100. Yay! Now let's move on to the second section, where we will be teaching you about circle graphs. This table shows the results of a survey of 160 students. You can also display this data in a circle graph. Circle graphs are used to compare parts of a whole. So you may think that this is just called a pie chart. It is called a pie chart. It's also called a circle graph though, because it's a graph that's in the shape of a circle. So in order to convert the data into a circle graph, we have to first find out what percentage of the circle is shaded, or what fraction of the circle is shaded. And there's also more complex stuff, but I'll add that after. So cycling, there's 25. So for cycling, there's 25%. And we know that that's 25 over 100, or 1 over 4. A quarter of the circle for cycling, which we can see here. Bowling is 40 over 100, or it's 2 over 5. there's 2 over 5 for bowling shaded, and inline skating has slightly less than 40%, which is 35%, and that's 7 over 20. It says since 40% is slightly less than 50, or 1/2, shade a little less than 1/2 of the circle for bowling. The remaining section is for inline skating. I need to teach you something, well, that's more reliable than this. Well, we all know that when we learn angles, we learn that a circle is 360 degrees, which is why sometimes when you see those cool moves in skateboarding or like snowboarding and others, there's a 360. And since it's 360 degrees, and a quarter is 90 degrees, well, what is a quarter of 360? 90 degrees. And what is 7/20th of 360 degrees? Well, that is equal to 18 times 7, and 18 times 7 equals to 6, and 6 plus 7 is 126. So 35% would be 126 degrees, which you could measure out with a protractor. And for 2/5, well, what's 2/5 of 360? 144 degrees. And then we label each section of the graph: inline skating, bowling, cycling. And sometimes you include the percentages or numbers, and sometimes you don't. Depends on what the teacher asks you and what the teacher likes. So let's do one with this. Favorite team sport? Well, let's draw a badly drawn circle. That's actually not too bad. Well, basketball has 60% of responses, so 60% would be 60 over 100, which is 3 over 5. Okay. Baseball has, oh, that's 25%. That's easy. That's a quarter. So let's just put out a quarter here. And usually for a quarter on the circle graph, you might want to include this little square thing. That indicates that it's a right angle, so it's 90 degrees, a quarter. And then that would be base ball. I can't fit the entire word on here, so I'm just going to use a hyphen. Done. And soccer is 15%. 15% is equal to 15 over 100 equals to 3 over 20. So 3 over 20 of 360 degrees would be 54 degrees. And 3 over 5 of 360 degrees would be 216 degrees. So we know that 54 degrees is, we're going to estimate this, so we know that it's less than this but more than this, so it would be around here, and this would be soccer. And the rest would be basketball. And that's 60%. Soccer is 15%, and baseball is 25%. If the teacher wants these numbers in there, then you make your writing smaller and you must put the numbers in there. Because if the teacher wants it there, you should probably put it in there because then you'll lose marks. We're at section 3 now, which is percents and decimals. Now, we can also write percents as decimals, just like how we can write fractions as decimals. Here's the steps that we go through. First, we write, let's just use 35%. 35% as a fraction. So that would be 35 over 100. So that would be 35 hundredths. And that would equal to 0.35. You can also write decimals as a percent. So you write 0.64 as a fraction. I'm going to teach you a shortcut to this after this. Then we write the numerator of the fraction with the percent sign. So 0.64 equals 64%. Now here's a shortcut. The moment you see let's just make it a random number, 2873. Let's do this. You don't need to write this as a fraction with 100 as a denominator. You just move the decimal point back 2 points. So you multiply the decimal by 100. And then this would be 28.73%. Easy, right? Much quicker. Don't do this unless you're used to it. Now let's do some practice to make ourselves used to it. Write the percent as a decimal. Well, 25% equals to 25 over 100. So that would be 0.25. 40 over 100 would be this, which equals to 0.40. Now you may be thinking, you don't need the 0 there. Well, if the teacher tells you to do the decimal to 2 decimal places, then you need the 0 there. If the teacher doesn't, and this number is exact, as in it is not rounded, then you can choose to omit it. But ask the teacher first. So 56% would be 56 over 100 equals to 0.56. And then 70% is 70 over 100, so that would be 0.70. So 93% would be 93 over 100. So that would be 0.93 because it's 93 hundredths. And then 3% is 3 hundredths, so 0.03. Now we do the reverse. Write the decimal as a percent. 0.25 equals to 25 over 100, which equals to 25%. Now, 0.9 would be 90 over 100, because think about it. Over 100, it always has to be to 2 decimal places, and 0.9 is only 1. So there must be something here, and that would be a 0 because you don't omit other numbers. So that would be 90%. As I said, you could just move the decimal point back. You don't need to do this step, but for the sake of getting used to it, we're just going to do it like this. 0.55 or 55 hundredths would be 55 over 100 or 55 hundredths, and that would be 55%. And 95 hundredths, 95 over 100, 95 hundredths, and then 95%. 51 hundredths, 0.51. 51 over 100. 51%. 0.04 is 4 hundredths, so that's 4 parts out of 100. And that would be 4%. As I said, you could just, for 0.04, you could just move the decimal place back 2, and then you get 4%. Yeah. So section 3 is done. Now we move on to section 4, where we teach you a problem-solving strategy. So to solve a big problem, you can solve little simpler problems instead. So last year, Jeff made 70% of his attempted free throws in basketball. If he attempted 70 free throws, how many did he make? So what do you know? Well, Jeff made 70% of his free throws, and Jeff attempted 70 free throws. So how many did he make? Is what we need to find. So we make a plan. So the plan over here, we have to solve a simpler problem. There's another way to do this though. So the simpler problem starts with, since 10% equals to 10 over 100 or 1 over 10, then 1 over 10 of 70 is 7, and 7 would be 10%. And since 70% is 7 7%, is 7 10%, then it would be 70% would be 7 times 7, because 7 is the amount that 10% is, and that would be 49. So check our answer. Does it make sense? If it's 30%, 30% would be 3 times 7, and that would be 21. 21 plus 49 equals to 70. 70 equals to 70. Our answer makes sense, and our answer is correct. Now, the other way we could do this is we realize that 70% is equal to 0.7, and then we just multiply 70 by 0.7, which also equals to 7 times 7. Hallelujah! Eureka! Right? So cool. Now, it says use to solve a simpler problem strategy. We'll do that, and we'll do it a different way too, probably. 8 chefs can cook meals in 3 hours. How many meals can 25 chefs cook in 6 hours? So if 8 chefs can cook 40 meals in 3 hours, then we know that 1 chef can cook, what's 40 divided by 8? 5. Can cook 5 meals per 3 hours. So how many meals can 25 chefs cook in 6 hours? Well, 25 times 5 is equal to how many meals 25 chefs can cook in 3 hours. So that would be 125 meals, but that's for 3 hours. How many 3 hours are in 6 hours? 2. So that would also be 125 times 2. So that's 250 meals. They can cook 250 meals in 6 hours. All right. So question number 2. An airplane flies at a speed of 500 miles per hour. If a train travels at 25% of that speed, how much faster does the plane travel than the train? So, honestly, you do not need to solve a simpler problem for this, because 25% is a quarter. It is very easy to use a quarter. So 1/4 of 500 would be 500 times the 1/4, which would be 500 over 4, and that equals to 125 miles per hour. So MPH stands for miles per hour, but we aren't done the question yet. The question is, how much faster does the plane travel than the train? Not how fast does the train travel. So now we have to do a subtraction. 500 minus 125 equals to 375. Of course, you could always say that 1/4 plus 3/4 is a whole, so you could just say 500 times 3/4, but we already did it this way, so yeah. The plane travels 375 miles mph quicker than, yeah, make sure you have enough space, so you should probably do all your work on a piece of scrap paper, than the train. Alright, that's done. Now we move on. Carla's alarm rings every 20 minutes for 1 hour each morning. How many times does it ring each week? I'm not sure why you would have an alarm every 20 minutes in each morning. Like, you would think that every 5 minutes is, oh, I want to get back to sleep for another 5 minutes. But every 20 minutes is a little strange. So, how many minutes are in an hour? 60. So we have 60 minutes in an hour divided by 20, and that's how many times it rings each morning. 60 divided by 20 equals to 3. How many mornings are there in a week? Well, there's 1 morning a day, and there's 7 mornings in a week because there's 7 days. So that would be 7 times 3, and that is equal to 21. And it rings 21 times per week. All right. Your brother has $60. He offers you either 40% or 3/6 of it. Wow, that's a nice brother. What amount should you take if you want to get the most money? And you're not being very nice to your brother. So, the question here is, which one's bigger? 40% or 3/6? So 3/6 simplified is 1/2, or you don't really say 1/2 this. You just say a half. So that is also 50/100, which is 50%. So which one's bigger? 50% or 40%? 50%. So I should take 3/6 of it. Done. Now we move on to question number 5. Ricky polled his classmates, poll means survey, and found that 40% of them named spinach as their favorite vegetable. 30 out of 100 of the class liked broccoli best, and 1 out of 10 liked carrots. Which vegetable does most of Ricky's classmates prefer? Okay, this is very strange because we know that 40% is equal to 40%, and 30 out of 100 is a fancy way of saying 30%, and 1 out of 10 is 1 over 10, which is equal to 10%. And if he polled all of his classmates, then 40 plus 30 and plus 10 equals to 80%. Somehow the rest of the 20% of the class is just gone, I guess. Anyways, ignoring that, we realize that 40% is more than both 30% and 10%. So most of his classmates prefer, and the 40% bit is, well, spinach, so prefer spinach. Done. There are a total of 500 students at Mary's Elementary School. Of that total, 40% of the students have a sibling who also attends the school. How many students have siblings at the school? Okay. This question is confusing. Technically, it's still 40% of the kids have siblings, because this 40% counts both the people that have siblings and the people that are siblings, that also have siblings. So it's still 40%. It's just that when you first read it, you get confused and you think that you have to do 20% of the number instead, but no, it's still 40%. So 50 times 40% is 40 over 100, which, if you simplify it, is really just 500 times 2 over 5, which is equal to 200. So 200 students have siblings at the school. All right. At the pancakes breakfast at Jenny's school, they have a pancake breakfast. I remember this one day where we used to have pancake breakfasts. We don't anymore. At the pancakes breakfast at Jenny's school, 250 people attended. Out of these 250 people, 60% were students. How many students attended? Okay, that's a lot of people that aren't students eating pancake breakfasts at a school. Okay. So how many students attended? Well, that would be 60% of 250, and 60% is 60 over 100, which can be simplified into 3 over 5. And that would be 250 times 3 over 5, and that is 150. I recommend that you actually do these calculations on a piece of paper or something, because it's easy to accidentally mess up unless you've been doing these calculations for a very, very long time. So 150 students attended. Well, we're at the last question of the section. Jeremy can cut 2 lawns in 2 hours. If Jeremy and his friend Nate work at the same speed, how many lawns can they cut in 5 hours? So if you cut 2 lawns in 2 hours, that just means that you cut 1 lawn in an hour. And if Jeremy and his friend Nate work at the same speed, then Nate also cuts 1 lawn an hour. So both of them together would cut lawns an hour. So how many can they cut in 5 hours? Well, if they can cut 2 lawns in 1 hour, then 2 times 5 is the amount that they can cut in 5 hours. So 2 times 5 is equal to 10. They can cut 10 lawns in 5 hours. Alright, so we're going to move on to section number 5. So now we're going to be estimating with percents. When you estimate the percent of a number, you are solving a simpler problem. Let's do a practice question. Estimate 48% of 197. So we know that 48% is around 50%. And 197 is around 200. So if it's 50% of 200, it would be about 100. So 48% of 197 is about 100. So we can check our answer by using the related multiplication fact. 100 times 2 equals to 200, which is close enough to 197, which is correct. So what is the actual 48% of 197? Well, let's do a calculation. 48% of 197 would be 197 times 0.48, and that it would be 94.56, which is close enough to 100. That's a healthy estimate. So now let's do some more estimation. Estimate each percent. So 22% of 98. So 22% is around 20%, which is 1/5. And 98 is around 100, so 1/5 of 100 is, well, 20. So that would be around 20. 46% of 257. So we can say that this one's around 260 because this one rounds to around 50. So 50% or half of 260 is 130. Now you might get slightly different estimates, but if they're around that, then it should be fine because you might be estimating it to 45%. Now there's also 18% of 192. So 18% again rounds to around 20%, and 192 can round down to 190. And that would be a fifth of 190 is 38. So that'd be around 38. Oh, 67% of 99. You don't even need to approximate this. You just say, oh, this is close to 100. So 67% of 100 is 67. Now, 29% of 208, you can say that 29% is close to 30%, and 208 is close to 210, so 30% of 210 is really just a fancy way of saying 3/10 times 210, which is 63. And for this, it would be 80%, which is 4/5, and 4/5 times 305 would be 244. Alright, so now that part is done, and oh look, we have pictures that we have to estimate, and word problem over here. So this looks to be around 50%. It's slightly less, but it's close enough. So we'll say that it's 50%. And this one looks close to 25% because, yeah, it looks close enough to 25%, so we'll just say it's 25%. Now we're on the word problem. You buy a shirt that is priced at $25. It is on sale for 25% off. About how much money will you save? It's very strange that some people will tell you to estimate this because the number 25 is a very easy number. So 25% is 1/4. And what is 1/4 of 25? Well, if you really wanted to approximate it, you could say that this is around 24, which is easily divisible by 4. So you would save about, a wavy equal sign is the approximate sign, so about $6. Well, we're done. And now we'll be teaching you how to find a percent of a number. We write the percent of a fraction of the decimal and multiply, which I've been doing for the past, well, while actually. Remember, of means times in this, or multiply. Find 40% of 20. So we write that as a fraction, which is 40/100, but that simplifies into 2/5. So 2/5 times 20 equals to, well, 8. And then 60% of $9. 60% is also a little bit like this one. It's 3/5 when you simplify it, times 9, because you have no cents over here, and you can't really have 0.1 of a cent or point anything of a cent, especially if you're actually paying at a store. So that would be, well, 27/5 equals to $5.40. And then there's find 140%. So 140% really is just 140 over 100. Or that equals to, well, 7 over 5. So now it's 7 over 5 times 20. So we do this again, and then 7 times 4 equals to 28. So you know how 100% is the entire of something? Well, if you have more than the entire of something, then you're going to have more than the something. So 160% would be 8 over 5 when you simplify it of, oh, it's still $9 times $9. And that would be 8 times 9 equals to 75. 75 over 5. And that equals to 14.4. Oh, $0. Well, let's do some more practice problems down here. Find the percent of each number. Well, 25% of 24. 25% is equal to 25 over 100, which is equal to 1 over 4. 1 over 4 times, well, 24 is equal to 6. So 25% of 24 is 6. 150% is equal to 150 over 100. And if you simplify this, you get 3 over 2. And 3 over 2 times 38 is equal to 57. Okay, 50% of $8. We know that 50% is 50 over 100, which is just 1/2. But oh look, there's 0 point over here. That means that we need to convert this into decimals. And 1/2 is 0.5. So 0.5 times 8 is, well, $4 and nothing. So 120% of $20. So 120% equals to 120 over 100. And that's equal to 6 over 5. So 6 over 5 times 20 is equal to $24. So our last two questions of this section, they don't give us a format. So 140% of 40. 140% is 140 over 100. And that is 7 over 5 times 40 is equal to 7 times 8 equals to 56. So then the next one we have is 80% of 14. 80%, we know this, we've done this so many times, is equivalent to 4 over 5 of $14, which has no sense, so we just write 14. That would be, well, that's 56 over 5 equals to 11.20 dollars. That's it for this section. Now we move on to section number 7. Another problem-solving investigation. This time we get to choose our strategy. Philip and his family caught a lot of fish over a 1-week period when they were on vacation. This Monday they caught 3, Tuesday they caught 2, Wednesday 1, Thursday 1. Oh, Friday wasn't a good day. Saturday they caught 4, and Sunday they caught 3. Philip fished on Monday, Wednesday, Friday, and Saturday. His sister, Nancy, fished on Tuesday, Thursday, Friday. Oh, she also fished on Friday, and Sunday. What percent of the total fish Philip caught did he catch on Saturday? So what do we know? We know that Philip fished on Monday, Wednesday, Friday, and Saturday. And the part about his sister isn't really important. So what do we need to find out? Well, we need to find out what percent of the total fish that Philip caught was caught on Saturday. So our plan is to, add up the total number of fish that he caught and then find out what percentage. So how many did he catch? Well, Monday he caught 3, Wednesday he caught 1, Friday he caught 0, and Saturday he caught 4. Well, 3 plus 1 plus 0 plus 4 is 8. And he caught 4 of them on Saturday. So 4 out of 8 is equal to 1 over 2. Is also equal to 50%. Is our solution reasonable? I mean, according to our calculations, it is reasonable. Reread the problem. Philip fished on Monday, Wednesday, Friday, and Saturday. So 3 fish, 1 fish, 0 fish, and 4 fish. His sister, Nancy, fished on Tuesday, Thursday, Friday, and Sunday. Fished on Tuesday, Thursday, Friday, and Sunday. What percent of the total fish Philip caught did he catch on Saturday? So we didn't understand the question the wrong way. How can you check your answers? Well, we could do the question again, and then we could see if it makes sense. So we got the right answer for that. Now, for the questions after this, we can look for a pattern, we can work backwards, or we can solve a simpler problem. Aisha read 24 books over the summer. So A read 24. Jamil read half that many. Well, that would be 24 divided by 2. Tay read twice as many as Aisha. So that would be 24 times 2. Zina read 3 times as many. 3 times as many as Yamil. So 3 times, so Yamil would be 24 divided by 2 in brackets. Shawun read 1/3 of the number of books that Zina read. So Shawun read 3 times divided by 2 over 3. Which 2 students read the same number of books? So let's simplify some of these, especially this one. So this one would be like this. And let's rewrite that now. Now that we've simplified this, we realize that Yamil and Shawun read the same number of books. So now we write that down. And read the same number of books. Done. So, the last question of the section. Hugo spent some money on school supplies. He received $5 back from the cashier. If he spent $95, how much money did he give the cashier? So, he spent $95. The cashier gave $5 back as change. So the amount that he gave the cashier would be 95 plus 5. That's 100. He gave $100 to the cashier. It's very simple. Now we move on to a subject that is considered easy in younger grades, but the moment you get into higher grades, it becomes one of those painful things you could do. It's called probability. You may have heard of it. So if you were to spin this spinner, it would land on A, B, or C. A, B, and C are the possible outcomes, or outcomes are basically what could happen. So for example, P, event, is number of favorable outcomes over number of possible outcomes. So basically the number of a specific outcome over the number of total outcomes. So in this one, for example, for A, there are 4 regions marked A. And there are 7 regions in total. So the probability of the spinner landing on A would be 4 over 7. Pretty good of a probability. And remember to simplify the fractions when necessary. Let's do this. Use a spinner at the right to solve problems 1 to 3. So we have x, which is 4, and z, where it's 2. So px, the probability of x, would be the total at the denominator and the number of sections that are x at the top. This is like having shaded sections for fractions, except the shaded sections are marked instead by a letter. And z would be 2 over 6, because there's 2 sections for z. And when we simplify these, it would be 2 over 3 and 1 over 3. Now, x or z, so basically both of them. That's all of them, so that's 6 over 6. And that is equal to 1. A probability of 1 is certain. A probability of 0 is impossible. So let's go on to the next question. Use a spinner at the right for problems 4 to 6. So probability of P, how many P's are there? 1, 2, that's an R, guys, 3. So it would be, how many are there in total? 10. So that would be 3 over 10. Can we simplify that? No. So we leave it there. And the number of Q would be 1, 2, 3, 4, 5. So that's 5 over 10. And that would be 1 over 2 if we simplify it. And question number 6 asks us for P or R. So R is this. So there's 2 regions marked R and 3 regions marked P. So 2 plus 3 equals to 5. So that the probability of P or R would be 5 over 10, which is also equal to a half, or 1 over 2. So now, after we've done probability, we move on to sample spaces. The set of all possible outcomes is called a sample space. There are several ways to find a sample space of various different situations. Now, we can use a list to find a sample space. At the fair, you decide to go on the bumper cars, the carousel, and the roller coaster. List all the different orders you can go on each ride, one time each. Make an organized list is what we can do. So B is for bumper cars, C is for carousel, and R is for roller coaster. And we have to use each letter exactly once because they told us that we are only doing it once. So we could go B, C, R, B, R, C, C, R, B, C, B, R, and R, B, C, R, C, B. Is that it? Come on, guys. Check for me. Is that it? Yes, that's it. So there are 6 different orders you can go on each of the rides. We can also use a tree diagram to find probability. Use a tree diagram to find how many pizzas are possible from a choice of thin or thick pizza and a choice of pepperoni, mushrooms, or green peppers. So first, we start with crust. We're going to use N for thin and K for thick, okay? Because they both start with T. Actually, they both start with THI. And a choice of pepperoni, we're going to use P for that, mushroom, or green peppers. We can only pick one of these. So then the topping is here, and we draw it like a tree. So the outcome for this one would be thin crust pepperoni, thin crust mushroom, thin crust green pepper. And then there's thick crust pepperoni, thick crust mushroom, and thick crust green pepper. So 1, 2, 3, 4, 5, 6. There are 6 possible pizzas. So there's also the other method. It's called multiplication. In questions like the first one, where there was 3 choices and they listed the amount of orders you could get, then you could do 3 because there's 3 spaces for you to do it. So the first one, you could do any 3. So then that would be 3. And then the second one, you could only do 2. And then this last one is whatever's left. So that would be 3 times 2 times 1 equals to 6. This is also the factorial method, because factorial is when a number is followed by the exclamation mark. It stands for that number multiplied by all the numbers before it, except, well, 0, and the negative numbers. That is used for when there's a certain order, and each thing is only used once. Now, there's also the multiplication method for these types of questions. So there's 2 choices for your first thing, and then there's 3 choices for your next thing. 2 times 3 equals to 6. If you have 4 choices for your first, and only 2 choices for your second, then 4 times 2 equals to 8. It's just multiplication. The number of choices for your first thing times the number of choices for your second thing, and if you have a third thing, you could even multiply that onto it. The multiplication method is the method that you use when you know what you are doing and you don't want to draw. So make an organized list or draw a tree diagram to show the sample space for each situation. Now, I will also be showing you how to use these 2 depending on which one. How many sandwich and fruit combinations can be made if you can choose from a turkey sandwich or ham sandwich with an apple, orange, or banana? So for this one, you can draw a tree diagram. So then there's turkey and ham. And then there's apple, orange, and banana. Apple, orange, banana. That is 6 combinations. You can also just put 2 times 3. The sample size is 6. So, second question. In how many ways can Kelly read 4 books, assuming she reads each book once? So let's call these 4 books A, B, C, D. So you could make a list. This is going to go on for a while, so I'm just going to skip this part. I'm back with this wall of combinations. That's 24 combinations. It would have been much, much easier if we used the factorial method, because 4 times 3 times 2 times 1 equals to 24. Just like the number that we counted, except this takes so much less time. Now let me explain why this is the case. So for the first one, you can have A, B, C, or D. For the second choice, well, you can't reread anything, so you only have 3 of them left. And then for the third, there's only 2. For the fourth, it's whatever's left. This is like drawing a tree diagram, right? Except, well, kind of inverted. So it's just the number of choices for the first one times the number of choices for the second one times the number of choices for the third one and times the number of choices for the fourth one. It's much quicker since you don't need to list out all of your combinations, especially if you have, say, 5 different things. Then that would be, well, 120 combinations. Imagine how easy it is to forget to list one of those combinations, or to accidentally forget to count one of them. So instead, we should use the factorial method. And now we're going to do some good old fortune telling, making predictions. Every 6th student who walked into school was asked how he or she got to school. This may sound familiar. It's called a survey. So a survey is a method of collecting information. The group being surveyed is called the population. To save time and money, part of a group, called a sample, is surveyed. A good sample is selected at random, or without preference. Say if you go and ask people what their favorite type of jam is, and you go to a peach jam making competition. You are going to get a lot of people saying peach jam. And that is, first of all, not selected at random, and it's also not representative of the population. Another example of not being representative of the population is if you're surveying 4 to 9-year-olds about teenage life. You're not going to get accurate answers. It also has to be large enough to provide accurate data. If you're surveying two people on what their favorite color is, the chances of them both saying the same type of color would be much more than if you survey 100 people and all of them say the same color. Okay, let's do an example. What is the probability that a student at the school rode a bike to school? Suppose that 10 people said that they rode a bike and 40 people were surveyed. So the probability of riding a bike, according to the surveyed sample, is 10 over 4, or 1 over 4, if you simplify it. So it would be 1 over 4, 0.25, or 25%. Now that we know that, there are 360 students at the school. Predict how many bike to school. Let's say S equals to the number of people who will ride a bike. So S equals to 1/4 of the population. And there's 360 people in the population. 360 times 1/4 is 360 divided by 4, so that's just 90. So 90 students will ride a bike to school. Simple, right? Now, use the following information and the table shown. Every 10th student entering the school was asked which one of the 4 subjects was his or her favorite. So, how many students were surveyed? Well, there's 10 plus 10, that's 20, and 15 plus 5 is also 20, and 20 plus 20 is 40. So find the probability that any student attending the school prefers science. Well, P bracket science equals to 15 over 40 equals to 3 over 8. This is also equivalent to 0.375 and 37.5%. So that's the probability. Now for the second question, there are 400 students at the school. Predict how many students would prefer science. Well, if the probability of them preferring science is 3 over 8, then, and we're doing a prediction, so it would be 400 times 3 over 8 equals to, well, let's do this. Let's simplify this. $150. So the prediction is that 150 students would prefer science. You could say we predict that 150 of the students would prefer, or you could say according to the data that we were provided, a prediction would be that 150 students prefer science. Or word it in whatever way you want. Just make sure that you clarify that it's a prediction and that it's 150 students that prefer science. Well, that's it for grade 5, chapter 9. See you next time.